Hello everyone, welcome to our questions about 2022. So we're gonna start from the first one, also the three-pointer questions. Let's read the question. Which box contains the most triangles? What are the keywords here, everyone? Yes, most what? Triangles, right? So the shape we're gonna look for are gonna be the triangles. And also we wanna find the box with the most triangle. So we just need to count. In each box, there are how many triangles? For the first one we have, circle it, only one. And for the second one, we have how many? 1, 2, 3, 4. We have 4. The third one, 2. And the fourth one, 3. And the last one, only 1. So if we mark the number in each option, it's easier for us to see, right? Actually, B gonna be the correct answer here. So for the first question, it's not that hard. As long as we can do it in order, it's actually easy to find the answer. So similarly, in the school math, what we learn or what we're gonna ask and test about is whether students can correctly name the shapes regardless of their orientations or overall size. So we know what are the shapes. And the second thing is we can count and distinguish between the different shapes. So for the school math, all those school practices gonna be similar with the Math Kangaroo problems. So we just need to see how many shapes in each of the, what are the numbers for each of the shapes here in this big and like messed up box here. So now let's move on to the second question. Eric cuts this picture in half and puts the two pieces together. Which option shows the two pieces of Eric's picture? So here, the most important thing is what? Actually, we need to figure out this is an original picture and we only have the patterns. We only have the measure on the surface, right? It's only on this side. But when I cut it, actually we can rotate the two pieces to make A, B, C, D, E, right? One of them. And we need to say which one is a correct one. So here for this question, we need to use our imagination. We need to think, what about if I rotate those pieces back to the original places? Will they be the same as the correct one here? So we can start with the first one. For A here, you can use your imagination, and also, if you're not familiar with that, my suggestion is you can actually cut it out and figure out. So here for the first one, what can we see? The left side gonna be the same. We don't need to change it. And then for the right side, you can imagine after rotate, do you think it's gonna be the same as this one, the original one? No way, right? So if I rotate it, you will see actually it will come back as this one, right? Do you think it's gonna be the same? No, right? So it's not A. So how about B? All right, for B, the left side is the same. And how about the right side? Okay, so now they already have the similar one. They are close to each other, but the direction is upside down, right? So B is not okay. How about C? So for C, you can see actually it's the same thing. What should I do? Do you think I'm gonna rotate this one and then rotate this one? No, right? I can actually exchange the position of those two and they are exactly like B. Since B is not correct, C either, right? Okay, so how about D? So for D, we need to do double time, right? So you can see here, if it is like this, I can rotate it and make it the left side as this. But how about the right side? Do you think it can be changed? No, they are face to each other, but the direction is also upside down, so D, not okay. And then the right one is what? E, we can check. For E, the left side, we don't need to change. And for the right side, we just need to do as turn around and make it like this. It is exactly at the original one, right? Okay, so for the previous question, we can see, as we mentioned before, it's all about what? Imagination, the spatial imagination. And for the spatial imagination, that question is exactly testing about the rotations, right? We can see whether we can understand and make the symmetry in two-dimensional shapes, and also we can use rotation instead of flip to figure out the original one. However, in the school math, even if we're talking about the similar questions, you will see it's more obvious. We just need to see what will be the symmetry line, and with the symmetrical lines, how can we figure out the missing part? All right, so that will be the difference. Math Kangaroo is already testing about the spatial sense, the rotation and the flip, but it is not actually covered or mentioned in the school math.